last stuff for today about these first computers, the ENIAC, etc. So these are computers that are filling up rooms. They're really heavy. When you turn them on, the lights in the city go down. They're using that much electricity, and they're not doing much more than what this would do, probably less, a lot less. And but the thing is, that was kind of the start. If you look at, I think it's, perhaps it was an earlier one, but these guys at that time, people didn't think that computers were, there was a big demand for computers, right? So what are we going to use computers for, right? You know, maybe the government will need one, maybe a couple other people will need one. There's not that much need for computers, it's kind of the thing that once the computers were sort of introduced, then we found all these uses for them. I mean, who would have thought that we'd all carry one around? Who would have thought that you'd need one of these in your pocket to get into the mall, right? You need it, right? You can't go into the mall without this. You have to have your INFS app working. So not only do you have to have a computer program in there, it has to be communicating with a server. And so over a mobile network, you know, all of this is computing. Every one of those things is computing. So we've gone a long way with that. And it's sort of getting into a lot of the stuff that we're doing. It's really kind of exciting, I guess. But, you know, when they first started with these computers, yeah, you know, maybe we're going to need 4 or 5 in the whole world. You know, that's what the IBM guy said. Maybe we'll need 4 or 5 of these big mainframe computers in the whole world. Who's going to use them, you know? You know, people doing the census. And then, you know, they found, well, actually, you know, the first supercomputers in Australia, who's using that is the tax office. So you could take whatever you want from that, right? So they want to know all about your income and stuff like that. So tax offices use them, big companies use them. So I mean, what about Amazon? That was the biggest company in the world a couple months ago, I guess, or years ago. I think now it's Tesla. You know, and before that it was it Google, or it changes very quickly, right? And, you know, before that it was Microsoft, and you know, then before that it was IBM. So IBM was just selling big iron. Now IBM's still around, and IBM sells computer services. They'll send in really smart people to a business and come up with a nice business solution, which is based around a lot of new computing. Yes, but it does a lot of this. So it's filling the space where the McKinseys were. That is doing consulting to companies to change the way they do their business, not just selling computers. So back in 1980, that's all they were doing, selling computers. And then along came Bill Gates, and Bill Gates was able to buy a operating system from some smart people he found in Arizona, I think, or maybe it was in Texas. He bought their operating system and he tweaked it a bit, and he sold it as MS-DOS. And IBM had a personal computer that they wanted to sell because they wanted to compete with these small companies that were making personal computers. They could see that there was a use for that. And Bill Gates was able to sell to them the MS-DOS to run on their personal computer. And so from that was like 1980. And then after that, he was able to bring in Windows in about, when was Windows? 1987, 1990, Windows 3.1. Anyways, I'm slowing down, so I gotta finish soon. I either have to have coffee or I'm gonna have to finish soon. So these big mainframe computers, there wasn't thought to be much use for them. The point that I'm trying to make is there really is a lot of use for them. Every government started using them. Every water authority started using them. You know, every insurance company started using them. And you may know people that are older than me that have been using computers for 50 years. Yeah, it went pretty quick to a pretty broad thing. However, they weren't nearly as powerful as what we're seeing now. Yeah, so where I'm going to stop is on this slide here. This fellow here, von Neumann. So as you said, why don't we hear about Germans? There's a German for you. Von Neumann came up with this very nice model. It's a conceptual model for how he thought a computer should work. So a modern computer should do these things. And so hopefully you can see some things straight away that you recognize. You got input and you got output, right? Input, output, processing. Input, output, processing. That's what we do in computing. So we need to know what is our input, what's our output, and then we can design the process to take that input and turn it into our output. And the process is done by the computer. Now, his idea was, well, we're going to have this thing that'll do that. We'll have this processing unit, a central processing unit, and parts within it, we would have a control unit. What the control unit is going to do is going to gather all of the resources that are necessary to do the processing, get them in the right place, and put them in the right order so that they happen. So that's a control unit that's going to be part of the CPU. And then also part of the CPU is going to be an arithmetic logic unit. That's where all the math is going to happen, multiplication, division, etc. It's also where you're going to, most of actually what they do in the CPU, in the arithmetic logic unit, is just comparing things. This is bigger than that. That's bigger. That's less than that. This is equal to that. So arithmetic logic unit is going to do a lot of comparison. That's very important if you're going to do sorting. A lot of what we do in computing is sorting. You got to sort things out. If you want to find something, first you got to sort it. You guys have made a lot of money for Google. I've made a lot of money for Google, right? We all use Google. What does Google do? It goes through the whole internet, finds all the stuff and sorts it so that you can find it. Before you can find it, first you have to sort it. So that's what Google did. So that's all happening in a bunch of arithmetic logic units. And then we have to have a memory space where we can store our data as we're processing it. All right. And then finally, we have some output. That's just telling me that the previous video has been processed. Okay, that's cool. And so I'm kind of going to leave you at that. That's in the corner. We'll talk about this in the next lesson. In the corner, you see a very, very, I was going to use the word basic, but I can't use that because there's actually a programming language called BASIC. So it's not basic programming language. It's a very, very rudimentary, simple. And when I use the word simple, I have to be careful with that. It's simple in that the instructions are simple, but you can't be a simple person to do this, right? I mean, you have to know about the computer, because basically this is saying, do you know this memory address here? Well, you're going to put that in that memory address. Then you're going to take this other thing that's in this memory address, and you're going to do this with it. Yeah, I mean, you really have, it's not a simple person that does this, but you got simple tools to work with. And then you write this programming language. Now, do people still do that? Yeah, there's a programming language that looks like this. It's called assembler. So assembler, what you're actually doing is you're getting right down into the memory of the computer. That's what you're doing, right? Memory address. In this memory address, do this. In that memory address, do that. Imagine that. I mean, the knowledge that you have to have of the actual computer to do that. So why would anybody want to program in that kind of a programming language? It sounds like way too much work. And of course, the reason is because it's very, very fast. Because you're working at a level of where the stuff is in the memory, and what you're doing is that you can make very efficient, fast programs. When I was living in Melbourne in the 1990s, I had a friend who lived there, and he worked for an airline company, and he was an assembler programmer. And that's what he used to do. He used to write programs in this kind of a language. Well, why would the airline want to do that? Because they have to have very fast programs, right? Because you want to get that seat on that airplane, on that flight, on that day or that time, right? So you book that seat, somebody else comes along 2 milliseconds later, too bad. So you can't put two people in the same seat at the same time, right? That would be really bad. So you must have a system that will sort of work with that. Now, some of you guys will go and do some database and say, oh yeah, we got ways of handling that without having to be too fast. We can do a lot of rollback checks and stuff like that. Yeah, but it is good to be fast. You want to beat your competitor. And so you want your customers, you don't want your customers to say to your customers, oh, just wait half an hour and we'll be able to confirm your flight. No, you want to say now, yeah, you're confirmed on that flight, on that seat now, because our program is faster than their program. And so, yeah, you got that. You get the idea? Anyway, so that's our introduction to computing for today. I'm going to stay here for another few minutes. You are free to go if you want. If you have a question, come and ask me. If you haven't signed the sign-on sheet, please do so. Is it there? Yeah. Thank you. All right. I'm going to stay here because I'm going to put this stuff on D2L. Only once. Is it Abdulaziz? Abdurrahman? Abdurrahman. No, that's the other one. So this is my previous class. Thank you, Abdurrahman. Yeah. What's your name again, mate?
My name is Omar.
Omar. Thanks, Omar. Haris. Sanshin. Haris and Sanshin. Thanks, guys. You know, it is hard to remember names, especially everybody's got a black mask on. Which reminds me, I got to put mine on. Haris. Okay, thanks. Ladies, before you go, can I get your names again? Hafsa. Hafsa. Zobia. You're the first Zobia I've met. You're not the first Hafsa. No, I have met a Hafsa before. The other ladies? Saido. Saido and Hanan, the first person in the class. Farida. Thanks, ladies. See you later. Oh, fuck it. 11.